if you want to determine whether one thing causes change in another, you need to use an experiment. An experiment is a study design where the researcher examines whether one variable causes change in another. Well, how would you do this? If you're trying to take that step from, all right, I've got the number of face masks in one column and I've got the number of Republicans in a county in the other column, how would I know that political affiliation is causing people to either wear a mask or not? How do you get at that level? Well, what you need to do in any experiment, and this is what makes it the gold standard of science, is that you need to be able to manipulate, of those two variables that you have, you need to be able to manipulate one of them. You need to actually be able to go in there and change that variable, intentionally do so, while controlling for others. So the only way you're going to be able to conclude causation is if you can actually control one of those variables and change it in some systematic way. You can then observe the effect of changing that variable on another variable. So in this situation in experiments, we're asking the question, how does manipulating X, variable 1, affect Y, variable 2? All right. I'm trying to make this clear by using an example that I think is important to understand because it is the basis on which we determine whether drugs are safe to use or not. Everyone is going to experience some kind of drug in their life probably at some point, whether it's recreationally or to use medically. Well, how do we know that if we take, say, an antidepressant, that antidepressant is actually causing a change in our depressive symptoms? Or if you are taking an Advil or a Tylenol, how do you know that pill is actually causing pain suppression, causing you to not feel that headache that you're suffering from? How do we know it's the pill's fault? If you were simply to look at, okay, I took an Advil and now later I feel better, all you've done is you've actually drawn a correlation. You've shown that when you taking Advil increases, you take more Advils, your headache decreases, you feel less pain. That's not causation, that's only correlation. Any of our personal experiences are only ever correlation. You need something a little bit more systematic to get at causation, and this is how you do it. So let's say that you're a pharmaceutical testing company. You are responsible for determining whether a drug that you have developed does what you say that it does. So your research question, let's say we're developing Paxil. Paxil is a type of antidepressant. So that is people with major depressive disorder, they tend to, they lose it. A lot of the common symptoms are you may lose interest in many of your daily activities, certainly feelings of sadness, but beyond that, you may have less interest in eating. You may have what are called self-defeating thoughts. That is, as you think about your life, you may consistently say to yourself, I'm just no good at that. I wouldn't be able to do that. Even if I tried, I would probably fail. So what's the point of trying in the first place? So depression, we'll talk about it in much more detail later in the class, but it is this collection of symptoms that together makes you less likely to do the things that you need to do to kind of live your life, survive healthily, and enjoy that life. Well, Paxil supposedly helps with that. So our research question as this pharmaceutical company that's developing Paxil is, does Paxil actually affect the human body in the way that we intend it to? And the hypothesis is Paxil will reduce symptoms of depression. All right, that's our hypothesis. The first step in an experiment is we need to identify the two variables. But because it's an experiment, we need to differentiate between these two types right here. a dependent variable, and an independent variable. A dependent variable, and this is usually the easiest place to start. If you're trying to identify whether one thing is a dependent variable or an independent variable, start with the dependent. The dependent is whatever outcome you will measure. So dependent means that something depends on something else, right? That if you are dependent on your parents, that means that whatever your parents do is going to have an effect on you. If your parents save up a bunch of money for you and then give it to you, that's going to affect whether you can go to college, right? So you are dependent on them. In this case above, what is the dependent variable? What is our outcome? It's going to be symptoms of depression. We think that the symptoms of depression are going to be dependent on whether someone's taking this drug or not. Excuse me. That's a dependent variable, so it's always going to be the outcome measure. In our example about face masks and the percentage of Republicans within a county, our outcome was what? We were trying to see whether percentage of Republicans determined the number of face masks. So the outcome is the number of face masks. Okay, the independent variable is within an experiment the thing that you're going to manipulate, the thing that you are possibly going to give in differing amounts to different participants within your study. So in our example here, Paxil would be the independent variable. We are either going to give people Paxil, or maybe we'll give them something else, either a lower dose of Paxil or a placebo, a control, a sugar pill, something that does nothing. So the independent variable is the thing you're going to manipulate. You're going to change. You're actually going to go in there and intervene upon it. Okay, now that we have the independent variable and the dependent variable, what we next need to do is we need to, again, operationally define our variables, which is something I think we have a little bit of practice now doing. So how will we measure or quantify our variables? Well, with drugs, what usually happens is you change the dosage. So in this case, Paxil dosage is going to be how we quantify the independent variable here. And the three categories I'm going to go with here are 60 milligrams, so mg stands for milligrams, 10 milligrams versus 0 milligrams, that is nothing, a sugar pill, or we don't give them anything. Then the dependent variable, how are we going to operationalize depression? How do we measure whether someone suffers from major depressive disorder or not? Well, again, if one of the symptoms is you have these self-defeating thoughts, you tend to have these, you think that you're unable to do certain things, and therefore it prevents you from doing them in the first place. We can measure that. We could ask people, perhaps in a diary, to report the number of times per day that you have a self-defeating thought. Reasonable. All right, let's graph this out. Let's make a table out of this. I want to show you what an experiment would look like. So on the very top, we have our different dosages. We have the 60 milligrams, we have 10 milligrams, and then we actually have two categories of 0 milligrams. One with a sugar pill, where we give someone something that looks like Paxil, but doesn't have any of the active ingredients. And then we have another one where there's no pill. And why we do this will make sense in a little bit. Okay, bear with me for right now. So what these are right here are the experimental and control groups. These are two terms you'll need to know. The experimental groups are the 60 milligrams and the 10 milligrams. In an experimental group, that is the group of participants that you are going to give the intervention to. In this case, we think that Paxil is going to cause a change in self-defeating thoughts. So when we give Paxil to certain people, they are in the experimental group. The other group is the control group. So the 2 0 milligram groups, those are controls. These are the groups that we're going to compare the Paxil groups to. So experimental and control groups. Okay. Below these, we're going to record the number of self-defeating thoughts per day. So on the left, thoughts per day, that's self-defeating thoughts per day. So let's say that we recruit 20 people for our experiment. They each are suffering from major depressive disorder, and one of the things you want to do is you want to, when you recruit people, you want to make sure that they are all relatively the same. So that is, you don't want any differences between each of your 4 groups other than the thing that you're looking for, the thing that you're investigating. So in this case, we see that we have, let's say that we're asking people to record this diary of how many self-defeating thoughts they have per day, and we take those 20 people, we divvy those people up into each of these groups, and so we have now people in the 60 milligram, 10 people in the 10 milligram, and the 20 milligram groups. And these people uniformly across all the groups report about 5 self-defeating thoughts per day. So they have 5 self-defeating thoughts per day in each of these groups. So they are uniform across these groups. What we'll then do is, starting at this baseline, we'll then give people each of these interventions. We'll give them the 60 milligrams, 10 milligrams, 0 milligrams. Then what we might do is we ask them to continue to record these self-defeating thoughts per day and do so for a week. We then average the number of thoughts per day that they have across that entire week. As we record this data, we then see that there are now, the people in this group average about 3 self-defeating thoughts per day. The people in the 10 milligram average about 4 self-defeating thoughts per day. 0, 4, and the other 0, 5. All right? We do that for another week, and we see that people in the 60 milligram group are only reporting 1 self-defeating thought per day. 3 for the 10, 4 for the sugar pill, 5 for the no pill. Okay? And we go that out, we take that out for about a month, 3 weeks, maybe into a 4th week. And by the end of this, we're seeing that there is a change, right? There seems to be a change between these groups. Now, the magic of an experiment, the reason that we can determine causation from this, is that the only thing that differs between these groups is what we've given them. Because we are the ones who manipulated what dosage of Paxil they got, we know that the only thing that changed between these groups is what they received. So here, the data looks fairly clear, right? So 60 milligrams, you got that full dose. It seemed to help with self-defeating thoughts. By the end, people were not reporting any. It seemed to have helped them with their symptoms predominantly. The 10 milligram, there was a decrease, but it wasn't very drastic, right? So maybe 10 milligrams helps some people, but it's not helpful for everyone. Some people might need a stronger dosage. We then see that there's a difference between the 2 0 milligram groups. In general, those sugar pills, or the no pills, the control groups, they didn't show much change. But the sugar pills seem to do something. Why? We'll figure out in a second. But that's the idea. This would be an experiment. The only difference between groups is what we've manipulated. Therefore, we can conclude that this Paxil is causing the change in the number of self-defeating thoughts per day. Okay, so the advantage of an experiment is that it does something called, it addresses something called a third variable problem. And this is a problem with, this is an issue, these are problems that you can't get rid of when you're looking at descriptive methods and you are looking at correlations. The problem with a correlation, let's take the example of SAT scores and GPA. If you were to correlate SAT and GPA, and you show that as people score higher on SATs, they tend to score higher in their first semester of college. It could be that SAT scores are actually causing change in GPA, but it could also be due to something else, right? What else could it be due to? It may not be that people who are better at taking SAT scores are actually more intelligent, that they are more capable of succeeding in college. It could simply be that the common third variable, the thing that explains both of them, is that these people tend to be good at taking tests. right? So if an SAT score is a test and your GPA in college is going to be determined by taking a test, what you may be measuring, what's actually causing the connection between those things is not intelligence. It's not how smart you are. It might just be whether you're good at sitting down and concentrating long enough to take a test, or tests make sense to you. That's a third variable problem. Let's look at our question of percentage of Republicans and the number of face masks. It could be that your political affiliation is causing whether you're likely to wear a face mask, but there could be a third variable problem. Turns out rural areas, places with not a lot of people in them, tend to be more Republican. Well, maybe people in rural areas are not wearing as many masks because they're not around a lot of other people, right? They don't tend, in a particular Walmart, the Walmart at Charleston might be packed with people versus the Walmart in Colleton, the one Walmart we have, may not have as many people. So people might be less afraid of contracting that disease. So they say, I don't really need to wear a Walmart because there aren't a lot of people in here. The chance of me getting a disease is probably not that great. So maybe the real explanatory cause is people are just not as worried because there aren't as many people around to spread the disease. Now, I wouldn't necessarily follow that logic because the virus can live on surfaces for quite a while, but intuitively, people might be thinking that. That's a third variable problem. So this is a major limitation of all other designs. Experiments allow us to control for that third variable. It allows us to pinpoint that this thing that we are changing. For disadvantages, experiments can create artificial results sometimes. Just as much as in a laboratory observation, you are very strictly controlling what people do. In experiments, sometimes you have to very strictly control things about your participants. If you are trying to claim that you're only manipulating one variable, you may have to restrict what your participants do to make sure that you are only manipulating that one thing. So it can be artificial at times. And it can also be expensive or difficult to administer. To do experiments well, you usually have to have a lot of people. You might have to follow them across time. And sometimes you can't experimentally manipulate something. For example, if you wanted to understand the influence of political affiliation on wearing face masks, how do you manipulate political affiliation? You can't actually tell someone, all right, these are your beliefs now you're part of the Republican Party, and you espouse all of the conservative beliefs that everyone in the party does. Or now you're liberal, and now you have these maybe more permissive attitudes towards things, right? Can't really do that. So in some instances, an experiment is either extremely difficult to do or possibly impossible. Okay. One thing I want to call out, and I call this out because I will see it when you write your research proposals. I know at least one person will do this, is they will design what's called a quasi-experiment. A quasi-experiment is when you compare two groups that were already different before they entered the experiment. So remember, to conclude that something causes something else, you have to manipulate it. The researcher must change it in some way. Well, why can't you have someone just enter already already different? Let's compare these two scenarios. So what's the difference between comparing two groups that are given Paxil or control, a placebo, versus two groups that are already taking Paxil or a placebo? What's the difference there? Well, if I give someone Paxil, they don't have the choice to do otherwise. They don't have something about them that would drive them to seek out antidepressants in the first place. So the only reason they're taking Paxil is because I said so, because I gave it to them. If you recruit two groups of people and one group is already taking Paxil, the other group has already taken nothing, it could be that the differences between those groups are due to the drug, but it could also be due to something else like personality. It could be that there's a certain type of person that prefers to take drugs to solve psychological issues versus someone who's not taking Paxil but is suffering from depression. They may seek out non-medicinal ways to solve that, or they might not want to put drugs in their bodies to resolve these kind of psychological disorders, for example. So again, it's not, if two groups come into the experiment, come into the study already different, if you observe any differences between those groups, it could be due to the drug, it could be due to your intervention, your independent variable, or it could be due to some background quality of the person, their personality, or some other trait that is actually causing the difference. In other words, quasi-experiments don't resolve third variable problems. Again, that's the unique aspect of an experiment. So if you ask people to come into the study already different, you're not controlling for those. Beware of quasi-experiments. They are okay, they are useful in certain situations, but you cannot draw causation from them. All right, a few other things I want to go over in this particular section. One is the difference between sampling, random sampling, and random assignment. These are two things that you need to do in any experiment, really in any study, but especially in experiments. Random sampling is when each person within a population has an equal chance of being recruited into the study. This goes back to my example of me creating surveys. If I want to make conclusions about how humans tend to date and mate, then I need to sample from a wide enough collection of people that I can say that what I'm seeing is true of people in the United States, is true of people in Indonesia, is true of people in Europe, is true of people from all over the globe. So if my population is humans, then I need to be able to randomly sample everyone within the world should have an equal chance of being recruited into my study. What this does is it increases the chance that the sample will be representative of the population. Okay, do not get this confused with random assignment. So if random sampling is that people who are not yet in the study have an equal chance of being in the study, random assignment is once they're already there, they're in the study, each person in that sample that you've collected has an equal chance of being in the experimental or the control group. So that is, if they're coming in for this Paxil study, they have to have an equal chance of either receiving Paxil or receiving one of those control groups, the placebo, the sugar pill, or nothing. Well, what's this going to do? If you put certain people, if you don't randomly assign people, what might happen is, let's say you take the policy of whoever is recruited into the study first, they all go into the experimental group, and then the people who are recruited later, they go into the control group. What might happen is the people who are excited to be in the study, they sign up first, they're real quick, might be very different from the people who sign up later, who then get put into the control group. So the difference between experimental and control might not be due to the drug, but rather, again, a difference between the type of people who got put in the experiment, who came first, who signed up first, versus the people who came later. It doesn't rule out those third variable problems. So random assignment is super important. Again, random sampling is everyone has an equal chance of being in the study. Random assignment is everyone has an equal chance of being in either the experimental or the control group. All right, there's another thing that we have to account for called the placebo effect. And this I was alluding to before. You may have heard of this. The placebo effect is when an expectation if you expect that something is going to help you, that an intervention is going to do something to you, simply having that expectation that it'll work means it does work. So it's it's when the expectation that a controlled treatment will work actually makes it work. Why would this happen? Well, let's say you're in a study and you're being told that you're given an antidepressant. You could receive the Paxil, which clearly will give you the physiological medicine it'll give you the medicine that you need to actually change your attitude. It'll change how your nervous system works. But if you receive a sugar pill, you at least believe that you're receiving it. And so what could happen is, simply by taking that pill, you might say to yourself, hey, you know what? I'm in this experiment. I'm doing something for myself. I'm taking this medicine, and it's supposed to make me better. Because I'm doing these good things for myself, that actually, it feels pretty good to actually get out of bed and just do something. It feels like I'm doing something for myself. That feeling of, oh, I'm doing something for myself, in and of itself, could make you feel better, right? So if you feel like I'm doing something for yourself, you might also be willing to get out of bed more. You also might be willing to exercise more, to eat healthily, because these are other things that you can do for yourself besides using Paxil, besides using this drug. So that's how placebo can lead to improvement. A sugar pill could actually cause you to improve if simply believing that you're doing something good for yourself is going to make you better. Now, how do you control for this? If we go back to the previous slide, we had the sugar pill and the no pill group. Well, the sugar pill is going to be the placebo group. They're actually receiving something, so they think they're receiving the treatment. Well, what we can do is, if we have another group where we don't give them a pill at all, then these individuals will go home thinking, well, I haven't done anything. I'm in this experiment, but they haven't given me anything. So they're not taking these extra steps. They're not actually just doing something that the people in the sugar pill group would be doing. So if you include this extra group, that controls for the placebo effect. That gets rid of, again, another third variable problem. There's also something called the experimenter effect, and that is when the experimenter's expectations or behaviors affect the outcome. I want to give you a very different, clear example of the experimenter effect. When I was an undergrad, I once had the hypothesis that I thought that dry erase boards, so actually drawing on a board, was going to be more effective for teaching students than using a PowerPoint slide. Well, what I did was I designed an experiment to do this, where I had one group where they learned a biology lesson using PowerPoint, and the other where they learned the same biology lesson using dry erase. And then they took a test, and then I compared their scores on that test. The problem that I made when I was running that study is that I was the one who taught the classes. So I taught the group that was learning through PowerPoint, and I taught the group that was learning through dry erase. What happens is, and what likely happened was, that as I was teaching with PowerPoint, I thought, okay, I actually don't think this is going to be effective. And so as I was teaching from PowerPoint, I was probably far less energetic. I was far less interested in actually teaching it with the PowerPoint because I thought PowerPoints are boring. Versus when I was on the dry erase board, I was moving around, I'm gesticulating more, moving my arms around, writing aggressively and very lively. And so, one minute. And so the difference between the experimental group of the PowerPoint group and the dry erase board may not have been due to whether I used PowerPoint or dry erase, but rather how excited I was to be teaching with one versus the other. That's the experimenter effect. To control for that, we use something called blinded studies. So there are two types of blinded study. First, there's a single blind study. This is when the participant doesn't know which treatment they're going to receive. So think about this. If you knew for 100% chance that you were going to be receiving Paxil, then you might, again, behave differently, not because the Paxil is actually having that effect, but because you know that there's a drug in your body and it's doing something. And so you might, again, be more positive. You might overcome those depressive symptoms, those self-defeating thoughts, simply because you know you're actually doing something. You're taking this medicine. And that might make it look like the drug is working. Versus if you don't know that, then you're always in the dark and you don't know whether to really believe, okay, you don't know whether to believe whether you're receiving the drug or not. And so that will, again, protect against the possibility that simply believing, knowing that you are using a drug is going to help you. That's a single blind study. So you blind the participant to knowing what treatment they're receiving. A double-blind study is when neither the participant nor the person administering the study, so the experimenter, the person who maybe is giving the drug, or in the case of my PowerPoint experiment, the person giving the presentation, the person teaching the students the biology lesson. They don't know who's receiving the treatment. This is what I should have done for my study. I should have gotten someone else to teach that biology lesson, and then never tell them what the experiment was about, just that they had to teach it. This would have controlled for the experimenter effect. That's what double-blind studies do. Not only does the participant not get biased by knowing what they're taking, the person giving the intervention cannot have their expectations shape what ends up happening in the study, the experimenter effect. All right, here is it's kind of an older, kind of drab-looking chart, but I find it very helpful for looking at the differences between each of these designs that we just went over, the descriptive methods, correlational methods, and then experimental methods. I recommend at least taking a look at this and going through it for yourself. Now, in the next discussion, here's a question that we have not answered yet, and I plan not to answer for you. But consider this, and this would be a great exercise for designing your own study. How would you experimentally test whether face masks prevent the spread of COVID? We'll talk about that.